So the topic of this presentation is MLOps and LLMOps. The motivation of this presentation is I want to talk about things that barely is touched upon. So we learn at courses, schools, universities, how to build a model. So they say, okay, you build this model and this is the accuracy and performance. Awesome. But no one tells you what's next. Okay, you build a model. What's next? What's going to happen afterwards? So the education stops at that point, and that's something we see happening from people coming from universities. They don't know what's happening in operations. So uh, before going forward, my name is Majid. Marzi has introduced me. I'm married. We have a son, and I used to be a software engineer, data scientist, and last 4 years I put more focus on data engineering and MLOps, mostly on Azure platform. So I want to talk about MLOps and what happens once you have a LLM model or you have a ML model. So I'm not going to tell you how to build a model, how to build the LLM. I want to talk to you about what happens when you go on production, what skills you need to have if as a next steps once you have an LLM model or you have an ML model. So you probably have seen this piece of article, or it was a newspaper. It was Harvard Business Reviews in 2012. So something like 13 years ago, 12 years ago, that the data science emerged and people got to know, okay, there's a data science, you have the data model, and you create some insight from that. It was very promising, so businesses and people loved it at that time. But what was data science before then? Before 2012? So that's the emerging thing. So what was before that? It's like what was data science in 2002, for example, 10 years before, and what was in 1990, for example. So at that time, it was some statistical analysis. So you could get some insight from the data with some statistics. Then Professor Tom Mitchell in Harvard University, if I'm not mistaken, he wrote a data called machine learning. And that was a revolutionary book that even his colleagues got against him. They say, oh, you are gibberishing. What is machine learning? Machine cannot learn. And so at that time, things are started. And machine learning and data mining started to create, coming to the universities. So this book, if you can see, Data Mining is the name of the book. It's from 2005. So I used to study this book in 2006. So that was one of our references, was it? So the first data scientists before emerge of the data science, or just after the emerge of data science, they were data miners. So data miners came into the businesses. So the thing is, the data mining was very academic based, but they get out of academia and put it in the business, and it became data science. The same decision trees and neural network in their first versions, they were what the data miners do. After 20 years, obviously these techniques are also evolved and got better, but the basics are still, they were available at that time. So what we learn in data science, if you go to classical approach of traditional or university, they say, okay, yeah, you need the data, you have to process the data, do feature engineering, you train the model, and you have to struggle with the model. And then once you get a good accuracy and performance, then you deploy it and you go home. And that's the thing that's a problem. You don't go home. That the second part of the story, a new chapter, starts when you deploy it, and that's what I'm going to talk about. So in 2014, Amazon used extremely talented data scientists at work to automate their hiring process. And they said, okay, there are lots of CVs coming in. Instead of a human going through CVs, at least we do the first round of filtering using machine learning. And then among hundreds, at least there are like tens of the candidates, and then we read the rest with hand, and we select we hire our engineers. So it turns later on, they had to shut it down after half a year, I guess, that they start discriminating women. This model was discriminating women. It was because in engineering there are mostly men, and the data is biased towards men, and the data scientists could not understand this. The model was biased, and they put it on the production, and it became discriminating candidates. So that's against the ethic of and norms of our society. So that was a good lesson that, okay, it's not just building a model that has 95% accuracy is good. There should be also explainable, it should be ethical, it should be monitored, and it should be explainable. So the challenges of classical data science flow is a scale. There are different challenges. One is ethic that I just touched about, but in general, it has a scalability issues. What happens? Okay, I put a model on production, and we expect 2,000 people call that API and call that model. What happens if instead of 2,000, 20,000 people call that API? The server goes down, obviously. And or what happens? How can I scale that model with the new data? So scalability is an issue. Reproducibility is an issue. Thing is, for example, I used to work for energy company. We initiated almost one every month or every 2 months one project. So the thing is, the data scientists wanted to do everything from scratch. I mean, we have the project. Why we cannot make templates that every time a new project initiated, at least we have like 10%, 20%, 30%, 50% of the work already ready because project at the end, they have lots of similarities with each other. And also, how can the results can be reproducible for testing later. Collaboration is a problem. Everybody teaches you how to write code, but no one teaches you how to collaborate with your colleague, how you write codes together, how run a big project that not only you are writing that project, you with the team you are going to write that project. So these things are never taught in the university, as far as I know, and that's a problem. And also deployment. Yeah, we call about deployment. You want to do it manually, or you want to have some deployment pipelines. How we challenge all deployment and how you want to deploy it in anyhow. So the thing they barely talk about, and observability, that also what I talk about, should be ethical, it should be right, it should be observe if the model has bias towards certain data, or after a while get a bias towards some data, or data are changing, or the nature of the business are changing. For example, if you are living in Europe, you probably know like with the Ukraine war, we had energy crisis, so the gas is got expensive, and if you have a model on production for energy company, um, your model is fine, your data is fine, but the nature of the market has been changed. How we can observe and how our model is scalable, that we can incorporate those changes. These things are, so I start the lecture with what is next. So these are the next. Once you made a model, you have to think about the scalability. You have to think about reproducibility. You have to, even during building model, about collaborations and deployment and observability. So MLOps is actually DevOps. So all these things that I told about you, it doesn't fall from tree at one point. So data science is following the footsteps of software engineering, and software engineers are further than us because they constantly write code and bring in production, and we can borrow knowledge from them. And one of the parts that in software engineering is about DevOps. DevOps is about continuous integration and continuous development and monitoring. So continuous development means people like you and I sit behind our computer, but with the right tooling, we can deploy together. The right tooling is like Git. So everybody clones a part of a code, works on it, and then commit it in a repo. Meanwhile, your colleague is also committing, and the code should be class-based, function-based, that we don't mess up each other's code. We just write modules, so it should be modular. So all this knowledge comes from DevOps. How can we work together as data scientists or the software engineers, how on the code level we can work together? And then once the code is ready, how there is a certain infrastructure that brings this code to the production, and how we monitor the model or the software. So model is also kind of software, right? Is a something in realm of software engineering. At the end, it becomes an API as kind of software. So how that piece of software of the model, later we can monitor it, that it works properly, is ethical, the accuracy 90% right now, maybe over 2 months is 60%. So how we can monitor that is all comes from DevOps. And DevOps makes life at the beginning more difficult, but when you go further and you work on big scale project, it makes life really easier. Any questions, comments? All right. So MLOps tries to bring DevOps to the data science. It helps you to collaborate, and it helps you to operationalize, to bring it to operation. So MLOps then the objective of MLOps is automate end-to-end ML workflow. It ensures reproducibility, scalability, and very important, monitoring. So key components of an MLOps, they are borrowed from DevOps, so version control. So we can, version is about version of the data, version of the model, and version of the code. So the data is subject to change every time we deploy a model or create a new version of the model, and the code is also changing. So how many of you already know or heard about GitHub, like code? You have heard, okay. Similar to that, for example, we have also, if you work with Azure, you have Azure ML, you have model registry, so you have version of the model. You can have the different version of the model and a different version of the database on your database. Testing is important. Um, yeah, it's not about trust, but the thing is, things are subject to change. Things are subject to break. So even your laptop and your mobile phone every time gives some error. So when we put data and put a model in a production and in a platform, we have to test it to see whether it's the same quality as we wanted or something break in between and the data or model or something has been changed. So testing is important. CI/CD about some pipelines for code integration for going on production is important, and monitoring is very, very important. So what are the benefits? Obviously, we can reproduce faster, and in general, the deployment is faster. We can collaborate, is observable, and it's scalable. So DevOps in long run, at the beginning, when I work with data scientists, they say, yeah, why you want to make my life more difficult? I mean, we are fine with this, but the thing is, once the project gets bigger and we go further, we avoid lots of headaches later. So what are the tools is MLOps? MLflow is the most famous one. So MLflow helps you with different things. For example, you log with the logging. For example, all the you can log your experiments, your with logging the code and the results. It also has a model registry, so you can register, and it also helps you to bring in a production. So it's kind of, it gives a flow to your ML operations. There are other things also like Kubeflow or TensorFlow extended. If you work with deep learning, you probably want to use TensorFlow extended. But what I personally use is Azure Machine Learning. So it's an environment, cloud-based of Microsoft that is easy, intuitive. You can do some things manually, some with the code. You can build up pipelines. It has model registry. They have thought about whole the flow of ML in this service. Yeah, so I like Azure Machine Learning. Is recently you have also Synapse and recently Microsoft Fabric. They try always merge it, make a bigger package, but the basics are similar. They create notebooks that you can create compute resources, and they have some CI/CDs. So the thing is, we need an architect. So we talk about DevOps and stuff. Okay, how does it look like? How these services should communicate with each other? How they should interact with each other? How is the flow of data? How is the flow of the model? How we observe it? So things are interconnected, and this interconnection, we can draw it and say it's an architecture, and that you can see it, for example, in this slide. It's Azure based. It can be AWS based or Google based, or it can be different. The choice is depend on the requirements, the compliancy with the company. For example, one company says no, we try to use as much as Microsoft native as possible. Some companies say no, I want to use less Microsoft. So there is some policies also within every companies that it gives you not always complete freedom. So based on the compliancy of the company and what you know and what these services can do, you have to think of these interactions. For example, here they said, okay, this is the data, and then you ingest the data, you put it in the Azure Blob, Azure Data Lake. And then with Synapse Analytics, you can process some of this data for BI users. So Power BI can see some reports on this. And then for machine learning stuff, there is a machine learning within Synapse, or you can use it, the external one. Through Synapse, you can get the data, build up your model, and once you build up your model, you deploy it to Azure Kubernetes services. So this is Azure non-native. Azure has also some other services, but this I got it from internet. You can see the source, but they chose Kubernetes and external. So what Kubernetes does is makes an API from your model. So users can interact now with here. For example, if suppose your API is about giving someone credit or not. It's a bank, and then they send some requests. For example, this customer wants a loan. Can I give the customer the loan or not? So this does some machine learning to calculate the risk of and says yes or no, or how much we can give this person the loan. So the good thing with Kubernetes and some containerized solution is if there is a few calls to this API, they use a few nodes, a few compute resources. And if there are lots of interest and lots of API, it can scale it up and use more compute and more resources. So in this way, you pay only as much as you use. You don't pay more than what you use. You can get, if it's on cloud based, if it's on premise, either you have to get a cheap server and only reply to few amount of API. If the APIs increases, the server gets down. Yeah, sorry, I don't have process and memory. Or you have to buy a very expensive server that maybe once in a year that server gets busy and you need the whole resource on that server. So it's waste of the money. But the thing is with Kubernetes and this kind of solution is they scale it up once it's needed, scale it down once it's not needed, and you pay as much as you use it. The day that you use lots of compute, you pay more to the cloud, and those days that you use less, you pay less. So this is how we prevent about scalability. So how this is one of the scalability factors that we guarantee that our model is scalable. So you need to be secure. You usually use Azure Virtual Network because hackers like to get into your model and crack it and hack it. And some people just like to hack everything and to make our life more difficult. And European Union is quite also concerned about the hackers, Russian hackers and Chinese, that everybody is trying. There is no company that I work and they don't get hacked, try to get hacked, at least on weekly basis. So that's the monitoring. We have to think about some solutions, how we want to monitor our model. For example, we have a data set. We can check this data set every day to say, okay, is still the accuracy is fine. We can monitor the health of this API. Is the API is working or is it down? So there are different metrics. You have to think about it, from accuracy, from being live and kicking, from drift, is this data is the same data or trying to do something else. So we have to think about different scenarios. And
Majid,
yeah,
sorry to interrupt you. There are also some questions. Do you want to answer them at the end?
sure.
Or?
Yeah, let me finish this and then question.
Sure.
And at the end, we need to indeed secure with the key vaults, and the container registry is the place that the models are saved or the containers are saved for versioning, version control. So if there are questions, please.
Yeah, I think Thomas, you had some question. Do you want to
Sure, yeah, I
read
can go
them?
ahead.
Yeah.
Yeah. So these are, I should say, a little bit provocative questions because I know there's there isn't always a good answer. I've been asking these because we work in a similar way using Azure, kind of similar MLOps workflow. So my first question is that, so in our drive towards full automation, are we risking a loss of critical human oversight that could catch subtle errors or biases, or what mitigating operations could you advise based on your experience?
Yeah, that's a good question. So we try to automate as much as we can, but it doesn't mean that we want to eliminate the role of human in the loop. At the end, for example, if you go to the production, everything is automated except that the button is pressed by a human to see everything is fine and there's still some checks. And this monitoring, it creates API like dashboards to inform us. At the end, then human interruption is that, okay, now it's getting deviated. Should I retrain the model? What should I do? So the human is in the loop, if that's the question.
Okay, yeah, I think that's very important. Thanks for that. My
Yeah.
second question is probably towards the same field. Um, it's basically about your experience on the growing reliance on these complex and sometimes opaque tool chains. Are these um, workflows hiding some crucial flows in the MLOps practices? So what's your experience there?
So I don't get the question. You are talking about different technologies?
So the crux would be that we've got these complex and sometimes not fully understandable
Yeah,
tool chains.
yeah,
Do
yeah.
you think that these could be hiding some flows during the entire MLOps workflow? Do
Yeah,
you have
so
any?
I think your question, how we can guarantee the transparency, right?
Yeah, yeah. So yes,
Yeah, they try to make dashboards of it. For example, how about the health of the nodes, for example, there are tools and there are Grafana and this thing. But the thing is, indeed, how transparent can it be? Because once it gets complex, you can crack it. That's your point, right?
exactly, exactly.
Yes, that is also a challenge of the whole thing, right? That's indeed that how we can. I don't have any concrete answer to that because and things are getting bigger and bigger, it can get out of control more and more. But the thing they try to make from different things the dashboard, and at the end we can use the health of the whole thing in a dashboard kind of thing. That's that's the tooling that I know
I see.
to for transparency.
I understand. Thank you.
Sure.
Majid, I also had a question of what metrics do you monitor in post-deployment to ensure a model is behaving as expected?
Yeah, I have it in the next slides.
Oh, great.
More questions? So let's go to the exactly. This is your question. There are different things like performance. For example, maybe the model gets slow, so we should call it and check the time. Is it like still timely, or it's getting the model is reacting very slowly, and what's the problem then? Data drift. So, for example, maybe some new data comes in which was not in the model training at the time of model training. For example, maybe the price of gas has never been €5 per cubic meter, for example, because of energy crisis. So we have to retrain model at that time with the new data as well. Logging and alerting, for example, that's mostly on how the model is operating, reading the logs. If it constantly fails to give answer, what's the problem? Or we can check the logs. And model drift is important. So to check, we talk about data drift here, but this is a slide about model drift. Means the model has been drifted away. So it's like is getting biased, or is not as the model that it was. One is that the data, the nature of the data has been changed. The connection of the data input and data output has been changed. For example, you are a telecom company and you do some churn prediction based on your internal data. Good. Your model is good, but now you have a competitor, is external factor. So for example, another telecom company is giving more competitive price and they are stealing your client. So the model is now has been changed. The relation is not only internal, but external factor is also playing this. So the model is not the model of before. So it's drifted. So we have to at this time get a new data, for example, from external factor or new set of data, create new set and retrain with current state of the market. Yeah, so model drift, there are different techniques. For example, you have to track the performance matrix, and there are some statistical stuff. You can do that. You can alert when it significantly underperform your model, and or just with regular training. Yeah, but if you have some external, for regular training, you have also better set of data. Then if there are some external factor, you have to include that also in your data and then retrain the model. So these are the techniques for monitoring and managing model drifts. So the other thing that MLOps offers to the data scientist is the quality. So it increases the quality of code. It increases the quality of data, quality of the model. Platform helps with platform stability and code security. So the thing is, as data scientists sometimes write the code that after 3 months they get back to the code and themselves they don't remember anything of that code. So that's a low quality code, and data quality can change in the course of time. For example, the schema can be changed, the data distribution can be changed, the data or the data pipeline can break at some point and give you rubbish data. And these are the things an MLOps engineer always has to guarantee. It's not only putting model in the production and monitor that, but as an MLOps engineer, for example, I was helping the data scientists to write better codes, write in classes, write in the methods, modular programming, writing tests for their codes. And we also have to think about model quality, as we discussed it previous slide. Platform, we have to also check the platform. It's like they call it heartbeat. The platform is running and kicking and is healthy, and the model in production is working, and code security. And the code not only should be modular and class-based, but also should, for example, I sometimes see they put API keys in the code, for example. The code is totally on, and then you commit it in a Git repo, and you just bring the whole company into security vulnerabilities. So there are different testing that the MLOps engineer should know about it and help with the data scientists to do that, like unit testing. So once you write a unit or a class or a function, you have to write some test. Integration testing is two modules are working or more modules working well together. That's a example of unit testing. If you write a procedure, for example, a square me, and then you try to write some tests about that. In recent years, companies are open, at least in my experience, get more exposure to Gen AI stuff like Copilot, ChatGPT, and within their own company in a secure way. And then one of these things, for example, once we wrote like module, we asked like Copilot to write tests. That was quite easy, and those technologies can write tests quite well because they can think different of scenarios, and it was quite easy and fast to write tests using this Gen AI stuff. But generally, once you write a function, there should be at least a few tests for that function. That's the norm. That's because if someone else comes and mess up with your function, suppose you wrote this function, square me, and someone, Mr. X, comes mess up with that because he didn't know well about this function and he thought it works like this. He brings some changes and it gets deviated from its logic. For example, the logic is just to make a square of that number. But if the logic is changed, all the tests are failing. And then you say, oh yeah, something happened. The code is changed. And this is very important because if the logic of this simple function is changed, the whole logic of your data science changes. So the error propagates from one function to the next functions. So it's important to keep watching all functions to ensure that the logic is not changing. So if the logic changes, the tests are failing. Data validation. There are, for example, for example, you train your model, you want to see if it's a valid data. For example, specific columns are numeric, specific columns are text, specific columns are date. Is the schema of the data is the right schema, for example? And also data drift checking, if the data distribution has been changed over time. And then you want to performance monitoring, like metrics like accuracy, precision, recall, latency in real time, and compare the current performance with the baseline to see if the model is degraded or not. Model drift detection, also see that if the model is performing or is drifted. platform, in old times when they create like motherboards, the boards here, they connected the motherboards to the power supply, to the power. And if the motherboard start smoking, they say, "Oh," so the engineers, they start saying, "Oh yeah, something is miss. They probably have some short circuit or something," and they stop working further on the board. So that test came also on our platform, especially on cloud. So we run some tests on the platform. If those tests fails, it's like it's coming a smoke out of the platform. So it means that the platform is down. Something happening. For example, I was wondering if you remember, it was like 6 months ago, the whole Europe Azure platform in the whole Europe was hacked by Chinese or Russian hackers, and for a half a day, the services were down, and so this smoke test that they all failed. So the platform was down, for example. And yeah, talk about code security. Code should be secure. You shouldn't include any vulnerable information, or the code should not do anything vulnerable to the platform. Part of MLOps is about explainability and responsible AI. So as I talked, your code should not discriminating some people or a group of people. For example, I was doing some analytics on never payers. So never payers are those, they get a mobile phone from a provider with their last iPhone, which costs like 1,500 or something. They get a subscription. They get the mobile phone and get the subscription, and they don't pay. And yeah, you can find those guys and get the mobile phone back, but that doesn't cost like first day. So the thing is how we could understand this person is a never payer or he would pay for subscription. It had a direct correlation with the postcode. For example, yeah, these guys are doing probably living in some places that but you couldn't use that because you are discriminating there are also good people in that neighborhood who are paying for mobile phone, right? So you have to be ethical. You have to remove all gender, postcode, ethnicity, this kind of data to be fair, and it should be transparent and it should be explainable. So I see that we don't have also lots of time, so I will go through LLM quickly. Do you have any questions so far? All right. So the thing is, you know about LLM. I saw also in the courses that there were lectures on LLM. I'm not an LLM expert. There are people who are making models. What concerns me is how they are operating, how they behave in operations. So from operation perspective, it's important for me. So I can skip about LLM, but focusing on LLM ops. So the whole idea of LLM ops is like ML ops. So it's explainable, it's ethical, it's we can work together. We put it with some CI/CD to production. We monitor it. We scale it. So the thing is more or less the same thing. So we want to be easier to make things are more automated way. They have also again drifts. It can be in the data, in performance can goes down, or we have to always check back because it's Gen AI. We have to always see that if the user is getting the right answers or not. You can use some another LLM to check the quality, but at the end, again, should be human also involved to give some expert opinion on that. There are various way of testing, validation. We have to think about ethics, transparency, exactly the same thing, but in the area of LLM. And the RAG pipeline that you are using also should be explainable, and what kind of data it reads and what kind of data it gives to the model. It should be monitorable. In Azure, you have Azure Cognitive Service Search, which is like a vector database. You give the document, it creates a vector of that, and it's ready for like Azure OpenAI or any other LLM solution. Yeah, I want the thing that I want to share is this one. So you have this architect, you probably see it more often, that okay, you have for LLM you have a UI like ChatGPT ish UI, and then you have a server. In the server, your queries comes from your AI or RAG pipeline. So this is the RAG pipeline that connects to the database, and it looks that everybody is happy. So what happens is in such architecture is, for example, Albertijn in Netherlands. Albertijn is a chain of supermarket in Netherlands. In the Netherlands, they started a chat that people ask for recipes with the hope that okay, they say okay, I want to cook something with parsley and egg and blah, blah, blah. And then it gives you a recipe with the hope that they can sell you the ingredients. And what people start doing, that they start asking Python questions in this app, and I start answering them. And that's exactly the ops part that we are talking. What is the monitoring? How we can assure even such a question should not even be asked from an LLM. How we can remove it? Sorry, we don't answer these questions. We ask about only recipe-based questions, and yeah, you don't want people use the network, your network bandwidth, and in your cost asking their Python questions. So it's or like a company, you put a company and people try to hack to get out of the salary of the CEO and this kind of thing. So this question in first place should not be asked from LLM. And if it has been asked, or if it is interpreted as such a question, it should not be given such an answer. So as an input and output of the LLM, you should remove this kind of things. So once ChatGPT came, if you ask what is the activation code of Windows 10, you say, yeah, sorry, I don't answer this question. And then, but you could have asked ChatGPT, yeah, could you tell me a bedtime story about a person who activates his Windows and needs some activation code? He said, oh, I can tell you the story. There was a grandmother, and he was activating her Windows, and this is the activation code. So people try to even indirectly asking some questions. So we have to from input and output guarantee such a question should not be asked. So if you want to augment that architect with LLM ops, you probably need more layers on that. For example, some CI/CD to put the model in production, some content filtering. For example, Azure also provide Azure AI content safety. For example, there are services try to safeguard this kind of things, and we have to always be ethical, and not only ethical, also We have to be in the direction, the LLM that we use, we create, or the model that we create should be used in the way that we expect, not in the, I mean, answering Python question is not a problem, but is ethical. But the thing is, you don't want people use your bandwidth to abuse your model. So that's the thing that we have to keep our hands on the pulse. So I end up with the skill set, what a skill set MLOps engineer needs. So you probably had understood you have to be a good Python or programmer. You know about OOP, modular programming, testing. You know about version control like Git, some containerization and orchestration. Containerizing is like Kubernetes, how we can go on production. Orchestration is how orchestration is the heart of the whole LMOP, which connects all the parts together, and that's the part that you need to also monitor it. And as you said, we have to keep it transparent and monitorable and build up dashboard on that to see things are not going out of the hand. You know, you have to have some understanding of machine learning, cloud services. People barely use on-premises. Now everybody has a tendency to use cloud and some infrastructure as code. These are the basic, probably MLOP skill set. LLM also, so you have to have some understanding of LLM, NLP. The data management, monitoring, security is more or less the same, but here you have to have also more. Is a bit, the nature is different. We have to also keep secure and compliant. LLM can easily go out of compliancy the results. So the MLOps and LLM ops is not the courses that are given in universities. And even in Udemy, I found only these two courses. There are not much courses. So people who go there in doing ML ops or LLM ops, they were software engineers or data scientists. They had to themselves learn like different pieces and put them together and make it like LLM ops or ML ops. So thank you for listening. If you have any questions.
Thank you, Majid. It was a very interesting talk. Everyone, do you have any questions for Majid? Or do you want to become an ML Ops now? Please don't be shy. Ask your questions.
Yeah, I think it can sound more difficult than it is, but you start from somewhere and then you build it up.
Yeah. Okay, Anka, you have a question.
Yes, sorry, I will not turn on my camera because I have a cold and yeah. So my question is regarding starting implementing a system, because for my company, for example, I'm working on a project and I'm the only one on the project because it's a side project.
Yeah.
And I'm working on implementing LLM system on Google Cloud, because
Yes.
the company has credits there, and I struggle just to think like, where do I start? It's a bit intimidating, and I found books describing getting into details and so on, but I still find it very intimidating. If you have any advice, how should I approach this? So it's not for a job, it's like to search for a job. I'm interested in this because I want to continue at this company, and if I manage to build this feature, there will be others. So yes. Any advice?
Yeah, sure. So I think the question is you are using some Google Cloud native services to build up LLM, and the question is how can I go on production?
I know about like the many services that are offered and everything, but yeah, it's still like if I could have I was searching for courses, like an actual course from end to end. I want to see someone doing each step, shown how they do it, so then I can adapt that to my case. But I cannot find any tutorial like this.
Yeah, the thing is Google, because yeah, if you look at there are a lot on AWS and Azure, because yeah, it's mostly adopted, the most adopted. Even Azure is even more, and Google is not that much, and it's hard to find resources to teach you. That's the problem, you say, right?
Yes, and I cannot find something an end-to-end project. That's what I would like to see. Like
Yes.
how it's done and then how it's maintained, everything. I would like to have a tutorial just to see how it's actually done, because I have no idea. Yeah, it's I cannot piece everything together. So I would like to see.
Yeah, the thing is, if if you want to keep it simple for yourself before going on production, really for the company, you need a UI to do your chat, and then you need a model and yeah, RAG pipeline. You can have it, or this. I mean, then only with this part you can start your training, right? So you can, and you need to see which Google Cloud service is like OpenAI, Azure OpenAI, that is like hosted, because I think you want to be Google native, so better to use Google's native services, and try to make your first model and start chatting with that, and then try to add a RAG pipeline, and then try to uh, call the API, and then try to add. So it's you start simple, and then you add every component next to it. And where are these tutorials? I don't know. I'm not a Google person. I don't use Google.
Yeah, I just sent the tutorial from Google here, Uncle. Feel free to take a look at it. But it also like I understand your struggle, but I didn't understand what's the goal. Like you're gonna make an LLM-based chatbot for the company. What is the application?
Yeah, it's a bit more complicated. So it's genomic chatbot, because it's actually a RAG system that is also connected to blockchain vaults. Is more
You have
complex.
also integration here.
Yes,
And
but I think like I want to first deal with the to create an MVP that's not integrated yet with the blockchain, and then the blockchain devs from the company can help me with that part. But I need to build an MVP to show how I basically connect everything. And I have some credits on Google Cloud, and I'm working on this. But yeah, I'm struggling a bit, but at the same time, I think this is a very important skill, because companies will ask for this. Like I would see a lot of startups that don't have that want to start working with AI and wanting data scientists to also do MLOps. because yeah, and it's an important skill. I agree, and it is fascinating at the same time. I would say, yeah, but
Because
it can be
I would
intimidating.
Yes, so that's why I suggest start easy, because it's not really that you want to go on production right now that you need all the components. Start easily with one or two components. And once you feel comfortable, add more component. But once you go live, and then you have to really think about that. But for your trainings, start easy.
And after it goes live, again, the part of monitoring, some resources for that, not necessarily for Google Cloud, but like in general resources, if you have some recommendation, because there are a lot of resources, and again, is overwhelming and hard to choose which one is the good one.
Yeah, I can understand. It's a headache because you have lots of technologies. Every day also they are changing, so you can't catch.
Yeah.
That's the nature. But um, for bigger project, you probably need more hands. Not only you have to be. So there should be a guy from platform that manage the platform. You work on like the model and rack pipeline, and there is another person who can ensure the quality. So you need, the thing is, the whole ops stuff is not one person thing. You need more hands, and you cannot, production ready is hard really to do everything one person.
Well, we have the devs. One of the devs can like they also do cloud. But they can adjust to this. But I would have to explain to them like what they have to do and everything, because they are not trained in MLOps.
Yeah, so there, if you find, for example, if you just search on Google, which, for example, for content filtering or for RAG pipeline, what are the best practices? And then you can do some parts yourself and some parts say, okay, to your colleague that you should use this technology like this, and let them to do the work. Because maybe I hear that the whole stack probably is difficult for one person. So try to tell them what to do, and give them also room to that they learn those things, and then to collaborate with you on that.
Okay, and do you have any resources that you would recommend for someone starting with MLOps? Because, like I said, I have found a lot of books, a lot of courses, but I need to just focus on
Yeah, the
which
thing
one.
is, the courses and the stuff is also very sometimes very basic or very broad, that not all of
Yeah,
them are needed. So I would say that if you can find some architecture on internet already from Google, on, for example, LLM Ops, your work, then you can see which components are involved in that architecture, and try to learn all those components. For example, in this example, I know that app server is an important component if I want to do this. So I would learn App Server or Azure AI Search or Azure OpenAI, and a bit maybe SQL or Cosmos DB or Blob. So the thing is, I don't have to follow that Udemy training. I just do these parts. For example, maybe starting from here, going from here, and then going from here. If you find, so the thing is, you need a reference architecture,
yeah, yeah.
and based on that reference architecture, you know which components are involved, and you learn those components. Yeah, we need also, so I'm also thinking now companies, they ask, ask, okay, what is your reference architecture? Yeah, we did something in like POC, proof of concept, a small thing, and we know that how difficult they are. And we are also thinking about architecture first, finding out which components are good, comparing things on internet. At the end, we have to come up with the architecture. Is it a good one? Yeah, we came up with this at this moment. So then we try to implement it, and then if we see any shortages, and try to improve the architecture.
Thank you, Majid.
Thank you.
Yeah, thank you too, guys, for listening, and good luck.
We enjoyed a lot, and I think the students will have access to your slides. I already put your LinkedIn in the chat, so feel free to add Majid. If you had questions, you can bother him later. And then
No
I just
problem.
say bye to you, Majid. We need to continue the course now.
All right.
Thank
Thank
you, Majid.
you too. Bye-bye.
See you
Okay,
later.
thank you. Bye.
Yeah.
Thank you
Thank you.
very much.
Bye.
Thank you, Professor. Have a nice day.
Bye.
Okay, guys, did you enjoy the talk today?
Yes, very much. And
Yes, very much.
it's a good tip, this reference architecture. Yes, I didn't thought about that, of course.
Yeah. So since this is the last session that we have, in your last part, you had some reading to do. There was an interesting paper from OpenAI. What I want you is for all of you to, we have breaking rooms. If Yash is here today, I'm not sure. We make some breaking rooms, so I want you to read this paper together. This is a very interesting paper from OpenAI. It's about how they handle, is about teaching the AI like ChatGPT to follow instructions better. So they found that just making the AI bigger doesn't always help. It can still say things that are wrong or harmful and so on. It still says. So they tried something new. They asked humans to show the AI how to behave, then use those examples to train it. After that, they let humans choose the better response and use that feedback to improve the AI model. This method is called reinforcement learning from human feedback. So I want you guys to read it together, and then I have a couple of questions to try to answer this together, and then come back. Can we have, Yash, like 3 breaking rooms?
Sure, Professor.
Meanwhile, I'll jump in since we moved to breakout rooms. I will stop the
Oh, yes.
the
Oh, yes,
live
please.
streaming.
Thank you so